Good afternoon, ladies and gentlemen. It's a pleasure to be here at the 7th ICAST with such a diverse group of lecturers and researchers from all over Indonesia and other countries. My name is Singgih Satrio Wibowo, and I'm a lecturer at Polytechnic Negeri Bandung, POLBAN. Today, I will present our research paper entitled Design and Development of Thrust and Moment Meter for Small UAV Propeller, which is important because this device is indispensable in measuring propulsion performance, which in turn determines the flight performance of the UAV. Let me share the screen. I will start with introduction, then discuss method and result, and finally end with conclusion. Let's dive in. Unmanned aerial vehicles have many benefits. They can be used for both civil and military purposes, including mapping and surveying, spraying pesticide on agricultural land, air or atmospheric research, mobile radio transmitter, border surveillance, combat aids, and even mobile weapons. Research in the field of small and micro UAV is relatively new in the world of research throughout the world, especially in Indonesia. One of the key aspects of the UAV technology is the propulsion system. The UAV propulsion system that is currently often used is electric propulsion, a propulsion system with an electric motor as a drive, which is then used to rotate the propeller. The suitability between the type of propeller and the motor's capabilities is an important thing that determines the performance of this propulsion system. The availability of motor performance data and also the propeller data used is absolutely necessary. The data is mandatory to conduct a comprehensive study of the propulsion system performance, which in turn determines the flight performance of the UAV. Several problems may occur at the stage of determining the combination of propulsion systems, especially the selection of right propeller, because both data are not always available. During this research, we cite other related studies, and we give here some of them that most relevant to our project. One, Bones, Mahoney, and Cork, they show the importance of propulsion modeling in controlling quadrotor. And two, Yoon performed experiment to quantify thrust dynamics. And three, Ramadani et al. Developing tool for dynamic thrust measurement. Our research process follow the flowchart as shown here. We start with review or observation of previous research, and then design and theoretical calculation of measuring instrument or device. And after this step, we proceed to making instrument prototype 1, including structure, software, and hardware. After making prototype 1, we do initial testing of measuring instrument. If the instrument can work according to the design criteria, then we proceed to the next step, verification test of measuring instrument system. But if not, we return to making instrument prototype 1. In verification, we compare the output with the reference data. The measure of success of this process is that the instrument output matches the reference data. If it does not work, then we turn to verification test. This verification process is repeated until a successful result is obtained. And then we can continue the next step: analysis, reporting, and paper writing. And the research process is complete. The result of this project can be seen in this slide. We start from electronic equipment procurement, then continue with electronic circuit development process, and finally make a complete device. The electronic component we use are one microcontroller, Arduino Nano, three load cell, three amplifier, and one OLED display. The electrical component of the device and the interaction between these components are presented here. We have two systems here. The first one is internal system or measuring instrument itself. It contains Arduino Nano, load cell sensor, HX711 signal amplifier module, and 126 times 64 pixel display screen. And the second system are external system, consists of user PC and propeller, ESC, power sensor, and DC source. And finally, we came to conclusion. First, the thrust and propulsion moment measuring instrument has been made and can work as planned. Second, the accuracy of the measuring instrument is 1% for static loads. Third, in dynamic loading, there is an overshoot in a time interval of less than 0.5 seconds after a change in load occurs, and then the reading became stable. Fourth, the maximum limit of thrust that can be measured according to the load cell capability limit use is 3 kg. Fifth, the maximum torque limit according to the load cell capability limit use is 2.1407 Newton meter. And sixth, the electronic system with embedded firmware has worked correctly and well as the interface software as a user aid has worked correctly and well. The last but not the least, we show here some of reference we use in our project. It is the end of our presentation, and thank you for your attention.